Hello and welcome. I am Dr. Pauline Fu. In this video, I will present ordinary general annuities. So I will introduce the concept for ordinary general annuities. And then I will compute the future value of ordinary general annuities. The keyword ordinary means the payment is made at the end of each period. For example, you make payment at the end of each month, each quarter, or each year. General means number of payment per year, PY, not equal to number of compounding period per year, CY. For example, you make a payment every month. Interest is compounded semi-annually. In this case, PY equal to 12 because 1 year you make 12 payments when you make payment every month. CY equal to 2 because interest is compounded semi-annually. So those are not equal. This is a general. Okay, PY not equal to CY. So let's take a look at examples. Payment of 100 made at the end of every month for 5 years, earn interest 5%, compounded semi-annually. In this example, the payment is made at the end. This keyword end means this annuity is ordinary. And then when you analyze how many payments is made for 1 year, a year you have 12 payments because you are making payment every month. And now, interest conversion period per year, CY, equal to 2 because interest is compounded semi-annually. Since PY not equal to CY, this is general annuity. General means PY not equal to CY. Okay. Again, the ordinary means payment is made at the end. So when you have a PY not equal to CY, when you have situation where PY not equal to CY, you need to calculate the equivalent rate per payment period. Okay, equivalent rate per payment period. To do that, we need to define new terminology, C. So the number of interest conversion periods per payment interval is C. So what is C? You use interest conversion period per year over payment per year, that is C. To interpret the meaning of C, C means number of interest conversion periods per payment interval. Once you have this letter C, so let's look at the examples. Numerator, denominator. Numerator means interest conversion period CY, denominator payment, number of payment per year PY. If interest is compounded monthly and you make payment semi-annually, what is C? If interest is compounded monthly, CY equal to 12. If you make payment semi-annually, PY equal to 2. By definition, C equal to CY over PY. So in this example, CY equal to 12, PY equal to 2, C equal to 6. Next example, interest conversion. Interest is compounded monthly, so CY equal to 12. You make payment quarterly. 1 year you make 4 payments. So what is C? C equal to PY over CY over PY. So 12 over 4, that is C, equal to 3. Okay, this example, interest is compounded quarterly, means CY equal to 4. Payment, you make payment once a year, PY equal to 1. So C equal to CY over PY, 4 over 1 equal to 4. Last example, interest is compounded annually, so CY equal to 1. Payment semi-annually, PY equal to 2. So C equal to CY over PY, 1 over 2, 0.5. So that is the calculation for C, number of interest conversion periods per payment interval. This is C. Okay. This is other examples. Okay, so if interest compounded annually, CY equal to 1. If payment made quarterly, PY equal to 4. So C equal to CY 1 over PY 4, 0.25. And if interest is compounded semi-annually, CY equal to 2. If payment is made monthly, PY equal to 12. So C equal to 2 over 12, 1 over 6. This one, interest is compounded quarterly, CY equal to 4. Payment interval, you make payment every month. So 1 year, 12 payments. C equal to 4 over 12 equal to 1 over 3. Next, last one. Interest is compounded annually. CY equal to 1. Payment monthly, PY equal to 12. C equal to 1 over 12. Okay. So now once we have C, we introduce equivalent rate per payment period, that is P. Equivalent rate per payment period, P. P equal to 1 plus I raised to power C, then minus 1. And C equal to number of interest conversion period per year, CY, divided by number of payment per year, PY. And I is periodic interest. Periodic interest. Okay. Periodic rate of interest. Okay. So this is a equivalent rate per payment period, P. Now let's look at the future value for ordinary general annuity. Remember what is ordinary? Payment made at the end. What is general? PY not equal to CY, that means general. When PY not equal to CY, you have to find P, equivalent rate per payment period. Okay, P equal to 1 plus I raised to power C minus 1. What is C? C equal to interest conversion period per year CY over PY. Okay, and this P would be the equivalent of interest rate in ordinary simple annuity. Okay, so whenever in ordinary simple annuity, the formula you see I, you plug in P, because here we have general annuity. Okay. So now let's look at the example. Calculate future value of ordinary general annuity. To attend school, Sam deposits $1,500 at the end of every 6 months for 4.5 years. What is the accumulated value of the deposits if interest is 6% compounded quarterly? Okay. So the question asks you, what is the future value? That is the question. What is the future value? Okay. We are going to use 3 methods to calculate future value for ordinary general annuity. Method 1, use formula. Method 2, using financial calculator. Method 3, using Excel. All 3 different methods would produce the same result. So let's use the formula first. Okay, and to use formula, we need to calculate P, equivalent rate per payment period. Remember P equal to 1 plus I, 1 plus I raised to power C minus 1. And what is C? C equal to interest conversion period per year CY over payment, number of payments per year PY, that is C. Okay. It is said interest compounded quarterly. Interest compounded quarterly. So CY equal to 4. And you make payment every 6 months. So 1 year you make 2 payments. PY is 2. PY represents number of payments per year. Okay. So C equal to 2. And I is a periodic interest rate. Okay. So I equal to 6% divided by 4 equal to 0.015. Once you have I, you plug in the formula for P, and you get the equivalent rate per payment period is 0.03. Okay. How do you interpret 0.03? It is 3% every 6 months for the interest. And once you have this number, you plug in the formula, this one here. Okay, future value formula. So future value equal to PMT, 1 plus P. This number is P, raised to power N minus 1 divided by P. And you get this number. Okay, so this is the formula method. The formula method, the formula itself is identical to ordinary simple annuity, except instead of using I, we use P. This is P. This is P. And how do you calculate P again? Here. This is calculation for P. Okay. So we did formula method. to calculate the future value for ordinary general annuity. Next, I will introduce calculator method. To introduce calculator method, we must make sure we have end mode. And then we have to set up PY, number of payments per year. And we set up CY, interest conversion period per year. Okay. And then we identify this number is PMT. And 6 is I, interest. And term N, you make payment for 4.5 years. 1 year you make 2 payments. So term N equal to 4.5 years multiply 2 equal to 9. So once you're ready for the number, you punch in those numbers into the calculator. Okay. Maybe I will put the calculator over here. Okay. So first, second, quit to clear any previous entries. And then second, the PY, type in 2, enter. Use down arrow key to get CY. CY is 4, enter. Now second, quit. Okay. And then type in 1500 negative PMT. 6 is the interest IY. 9 is the term N. Now you enter the 3 numbers. Remember, you always need to enter 4 numbers. Okay. So next number you need to enter is the 0 PV as precaution to clear any previous entries. Last step, compute FV. Okay, and this is the future value. It is the same number as we get using the formula. Okay. All right, so last method to calculate future value for ordinary general annuity. We need to use Excel. Okay. And to use Excel, we need to calculate P. Okay, in Excel, P is the equivalent rate per payment period. Okay, so P equal to, just use this formula here, this formula. Okay, calculate P. P equal to 1 plus I. I is 6%. Compounded quarterly divided by 4. Okay, raised to power C. C equal to, C equal to CY. CY is 4 over PY. PY is 2. And then minus 1. This is P. 1 plus I raised to power C minus 1. Okay, this is P. Okay, and this P would be interest in Excel formula. So what we are asked to do in this question, future value. What is the future value? So rate, this number is rate. Okay, this is your P. Common. NPER is 9 payment. PMT negative 1500. Present value is 0, type is 0. Okay, so press enter, you get this number. So you need to change the format to number, not percentage. Okay, maybe keep 2 decimal place. See, this number is exactly the same as we get from calculator. Okay. So this is a calculate future value for ordinary general annuity. We did calculate a license here. Okay. All right, in summary, what we did in this lecture, we introduced some basic concept about ordinary general annuities. Ordinary means payment is made at the end. General means number of payment per year, PY, not equal to number of interest conversion period, CY. When PY not equal to CY, you need to calculate P, equivalent rate per payment period. You need to use this formula, calculate P. And then you can calculate the future value using this formula here. Future value for ordinary general annuities. Okay. All right, that's all for this video. Thanks for watching. See you next time.